Good day. Today we're going to deal with a type of question that says for which values of x will f at x divided by h at x be greater or equals to 0? So, let's begin. So, I call this level 3. Let me just show you an example of level 1 and level 2 before I get to this level. So, this was level 1. If you want a detailed video on level 1 and level 2, please watch the video that is part of the playlist. So I would advise you to watch the first video of the playlist, which is found at the end of this video. That video is also found right here on the top right of the screen at the suggested video. So let's deal with level 1 just for a moment. So the question says for which values of x will f at x be greater than g at x? So what you will do is that whenever you see this level where they're asking you about one graph being greater than the other, what you'll do is that you'll focus on the points of intersection strictly. So you focus on the point of intersection strictly. So as you can see, the points of intersection are this point and that point. So what you will do is that after you've located a point of intersection, you will draw vertical lines. So you draw vertical lines that cross that point of intersection. And then now let's check how many groups do we have. We have got group 1, we have got group 2, we have got group 3. So these are 3 groups. So these vertical lines have separated the whole Cartesian plane into 3 groups. So f at x is the y value of x and g at x is the y value of g. That is why sometimes when you see f at x, you usually substitute it with y. So if you see them saying f at x must be greater than g at x, this just means that the y value of f must be greater than the y value of g, meaning that in the graph, f must be on top of g or higher than g. So whenever f is on top of g, we can now say f is greater than g. So let's check in group 1 if it fulfills the requirement. So f is the parabola and g is the straight line graph. So in group 1, notice that g is on top of f, right? G is on top of f. The graph of g is higher or is above the graph of f. So it does not fulfill the requirement. Alright, let's check group 2. So in group 2, we have the graph of f being on top of the graph of g. So it fulfills the requirement. So this group fulfills it. Let's check the next group. So you have to be sure to check all groups because for some type of questions that can come out. So in group 3, the graph of g is higher or is above the graph of f. So it does not fulfill the requirement. Now that we're done with the group, now we have to describe it. So now we have to describe the values of x. Notice that this portion, this group starts from -4 and it ends at 1. So I'm going to show you how to describe it in interval notation and inequality notation as well, because in the previous video another student asked me to show them also in inequality notation. So we can see that it starts from -4 and it ends at 1. So notice I'm not looking at the y value but rather the x value, because the question says for which values of x. So in interval notation, we'll say x is an element of, where does it start? It starts from -4 and it ends at 1. So we'll tell them it starts from -4 and it ends at 1. Then how do you know whether it's square or curved bracket? According to this question, we have greater than only. So it means wherever numbers will be, it will be curved. But if the question said greater or equals to, it means that they would be square. So this is interval notation. Let's talk about inequality notation as well. So we notice that it starts from 4 and it ends at 2. So it's between these values. So you will say x is between -4 and 1 because it's between -4 and 1. And then the next thing you'll do is that you'll just put inequality signs this way. So they will always face this way whenever we're talking about x in the middle. Now, if the question just says greater than, then we'll leave it like this. But if the question says greater or equals to, then we'll also put equal signs. So this is how you describe it in both interval notation and inequality notation. So here is the second level. Just before we go to the third level, let's just delete one question pertaining to the second level. And if you want a detailed video on the first level and the second video, it is found at the end of this video at the playlist, the first video of the playlist. So this question says for which values of x will f at x times g at x be less or equals to 0? So now this is level 2. Level 1 is whenever they're telling you one graph must be greater than the other, right? And notice this, you cannot take it to the other side and make one graph being greater than the other, because there is not a subtraction sign, but rather there is a multiplication sign. So this is level 2. Whenever they say one graph times the other graph must be greater or equals to 0, or they say less or equals to 0. So for which values of x will f at x times g at x be less or equals to 0? Now in this level, we do not focus on a point of intersection as before. Level 1 will strictly focus on a point of intersection, but in level 2, we focus strictly on the x-intercept of each graph. So you have to focus on the x-intercept. Wherever you see x-intercepts, you have to make sure you draw vertical lines at all x-intercepts. So there are 3 vertical lines. So how many groups do we have? So these 3 vertical lines separates the Cartesian plane into 4 groups, because now we have group 1, we have group 2, we have group 3, and finally we have group 4. So these 3 vertical lines separates the Cartesian plane into 4 parts. So now what you have to look at is in level 2, notice one graph times the other graph must be less or equals to 0. Now notice you have to talk about their signs. Remember, this is the y value of one and the y value of the other. So let's talk about these signs. So if they say f at x times g at x must be less or equals to 0, they're saying f at x times g at x must be negative, right? Because in functions, they don't like saying it in words. If they say a is greater than 0, they are indirectly telling you that a is positive. If they say a is less than 0, they're indirectly telling you that a is negative. So if you see them saying that less than 0, it means it must be negative. So if you are saying less than 0, it means that it must be negative. So what gives a negative answer? What gives a negative answer is whenever you've got positive times negative or negative times positive. So that's what it means. So it means that if the y value of this graph is positive, the other one must be negative. If the other one is negative, the other one must be positive. So let's check group 1. Now notice this is the x-axis, the blue line. So whenever the graph is above the blue line, the y value is positive. Whenever it's below the blue line, the y value is negative. So if you look at these 2 graphs, you would notice that both of them are underneath this blue line. So meaning that they're both negative. So they're negative, negative. The y values are negative because they're on the negative side of the y value. So does it fulfill? It doesn't fulfill. They have to be different. It has to be positive times negative or negative times positive. So group 1 does not fulfill. What about group 2? Well, in group 2, this one is above the blue line, so it's positive, and then this one is below the blue line, and it's negative. Well, it fulfills because we wanted them to be different. So we wanted the signs to be different. So if one is positive, the other one must be negative. So it fulfills. What about group 3? Well, group 3, notice that they're now both above this blue line, right? They're above the blue line. So this one is positive, and also this turquoise graph is positive. So positive and positive. Does it fulfill? No, it doesn't fulfill because they both have to be different for them to give a negative answer. So let's check the final group. So in the final group, notice that this pink graph is above the blue line, and also the turquoise graph is below the blue line. So now this one is negative, this one is positive. Well, it fulfills. They are different, right? The signs are different. So therefore, this group works also. So now we have to describe group 2 and group 4, because we have group 1, group 2, group 3, group 4. So we have to describe group 2 and group 4. So we'll describe it both in interval notation and in inequality notation. Then we'll go to the third level. So let's describe group 2. So now notice group 2 starts from -4 and it ends at -2. So it means you'll say in interval notation, you'll say x is an element of, it starts from -4, then it ends at -2. So it ends at -2. And then let's talk about the bracket. Should it be square or curved? So now the question says less or equals to. So because of that, we'll put it as square on both of them. So now we're going to say or. So now let's describe the fourth group as well, since it was also the one that worked. So the fourth group starts from 2 and it has got no end. So it starts from 2 to positive infinity. So then you will say it starts from 2 and it ends at positive infinity. So now notice With 2, it will be a square bracket because of the question. And then infinity always has a curved bracket. So we've described it in interval notation. Let's also describe it in inequality notation. So in inequality notation, let's describe this stuff. So notice it is between -4 and 2. It has a beginning and an end. So -4 and -2. So you'll say x is between -4 and -2. And then the signs will always be facing this way. They will not face that way whenever x is in the middle. So it will face this way. And then because of the question, we'll also put equal signs. So this is just one group that we've described. We also have to describe this group. So now we'll say or. So here we say it in words. We'll say or. Notice it starts from 2 to infinity, so there's got no end. Well, in inequality notation, we don't write infinity. So since the arrow is pointing that way, it means that it must be greater than 2. So you'll just say x must be greater than 2. But because of the question also, you'll put equal sign. So that's how it is. Whenever there is no end, you'll just say it's greater than 2. Yeah. Whenever there is no beginning, you will say it's less than. So that's how it is with inequality notation. All right. Finally, let's move to level 3. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. All right, now let's look at level 3. Well, level 3 is very easy. It's just like the second level, except that on the second diagram after this one, I'm going to show you one slight thing, but they're the same. So if they say for which values of x will f at x divided by g at x be less or equals to 0. So now we want the divisions to give us a negative. So in order for the divisions to give us a negative, it has to be positive divided by negative or negative divided by positive, right? We know that the rules of multiplication and division are the same when it comes to the signs. So before I draw vertical lines, you have to be careful of this. This is what can catch a lot of students. So now notice that f at x divided by g at x. Now you agree with me that whenever we have got anything divided by 0, it is undefined. If you type anything, maybe even in the calculator, if you can type anything, maybe if you can say 100 over 0, you'll see that it's undefined. So anything over 0 is undefined. So anything over 0 is undefined. So in other words, g is not supposed to be 0, because if g is 0, it will become undefined. So this is what you're going to do with the vertical lines. First, you'll draw the vertical lines as usual. This is like level 2. In level 2, we'll focus strictly on the x-intercepts of every graph. So now we'll draw first vertical line over there, the second vertical line, and then the other vertical line. So it separates the graph into 4 parts, the Cartesian plane into 4 parts. Then what you'll do is that you notice that g is not supposed to be 0. So what you can do to help you is wherever this graph is 0, you will not have one vertical line, but you'll have 2. So let's check, where is g at x equals to 0? Well, g is this graph. So this graph becomes 0 when x is -2. So we'll draw a double vertical line just so that it can remind you. So I will show you what does this affect. All right, so the double vertical line, please don't take this as another group. We're just taking this as one line. We're just drawing 2 lines so that it can remind us. So this is into 4 parts, right? Group 1, group 2, group 3, and group 4. So they must be different, right? One must be positive, one must be negative, or one must be negative, the other one must be positive. So let's check if it fulfills. So does group 1 fulfill? Well, the pink line is below the blue line, which is the x-axis, so it's negative, and also the turquoise graph is below the blue line, so therefore it's also negative. So it does not fulfill. So it doesn't fulfill because they both have the same sign. So let's talk about the group 2. So in group 2, this graph f is above the x-axis, and then J is below the x-axis. So F is positive, J is negative. Well, it fulfills because they're both different. If we divide them, they will give us a negative answer because this thing must be negative. And then let's check group 3. So in group 3, this is above, so it's going to be positive, and this is also above. It's above the blue line, so it's also going to be positive. And then it will not fulfill. So let's check the final group. So in the final group, we see that the pink line is above, so it's positive, and the turquoise graph is below the blue line, which is going to be negative, so it's going to be negative. Is it going to work? Well, when we divide negative and positive, it's going to give us a negative answer, which does work, so it works. So we have to describe this group and this group. So let's describe group 2. So we'll say in interval notation, we'll say x is an element of. So notice it starts at -4 and it ends at -2. So we'll say it starts from -4, it ends at -2. Now let's talk about the bracket. With this one, must it be curved or square? Well, according to the question, it must be square because it's less or equals to. And then with this one, well, we have to be careful. We've got a double line here. This double line tells us something. It is not supposed to be 0. So whenever there is a double line, it will always be curved. So you will just make it curved, irregardless of the question, whether the question says less or equals to, whether the question says less than, whether it says greater than or greater or equals to. So it will always be curved. So that's what the polar line is for. The reason it's curved is because we can't, whenever we put a square bracket, we're saying that it's also allowed to be equals to 0. But then this part is not allowed to be equals to 0. So that is why we exclude it, even though the question says it must 0 must be included, but the denominator cannot be 0, so we have to exclude it. So for the first part, 0 is included because the numerator is allowed to be 0, which will cause the answer to be 0. But anyways, even if you didn't understand my statement, do not worry about that. The only thing that you have to memorize is that wherever there are double lines, it's gonna be a curved bracket, regardless of the question. And then we're gonna say or. So now we have to describe this group. This group starts from 2 until infinity. So it starts from 2 and then it ends at infinity. Infinity always has a curved bracket, and then when it comes to these two, we just have to look at the question. The question says less or equals to, so we're gonna put a square bracket. So there we have it. We have described it in interval notation. Now let's describe it also in inequality notation. So describing group 2, it starts from -4 until 2. So x must be between, so it's gonna be from -4 until 2. Now let's talk about the signs. The signs we know is always gonna be like this. Now the question says that it must also be equal. We're supposed to do this, but we have to be careful. There is a double line where there is -2, so therefore we only put less than, so we don't put equals to. And then we're gonna say or. So we're gonna say or. Then let's describe this group. So this group starts from 2 and it has got no end. So because it starts from 2 and it has got no end, you will just say x must be greater than 2. So because the arrow points to the right. And then now notice something. The question says less or equals to, so we put an equal sign there, as long as it doesn't have the double line. If it had a double line, then we were not gonna consider it. Alright, here is another level. Just before we do this level, if you are interested in knowing the prices of the tutorials, the video that contains the prices and the updated contact details, just in case these ones have changed, is found at the end of this video. So the set for which values of x will f at x divided by h at x be greater or equals to 0. So this is different because it's a hyperbola, and in a hyperbola we've got an asymptote. Now vertical asymptote also play a role whenever you're drawing vertical lines, whether it is in level 1 or level 2 or level 3. Whenever we've got vertical asymptotes, we also count it as part of the lines. What do I mean? Okay, let me illustrate it. Alright, let me explain it. Let's just call the vertical asymptote x is equals to 1 and the horizontal asymptote y is equals to 2. So let's call the straight line graph f and the hyperbola h. So The question says, for which values of x will f at x divided by h at x be greater or equals to 0? So it means the result that we want must be positive. So for it to be positive, it must be positive divided by positive, or it must be negative divided by negative. Those two results give us positive. So as usual, this is just like the second level. So we have to draw vertical lines on every x-intercept that we see. So yep, these are the only two that we see. So usually we would say this is group 1, this is group 2, and this is group 3. But now this is done slightly different. It's done different in that the vertical asymptote is also considered as a line. So if you want, you can draw a line by the vertical asymptote. So this is separated into 4 groups. So we've got group 1, group 2, the small group there, group 3, and then we finally have got group 4. So we want them to have the same signs so that the answer must be positive. So let's check in group 1. Do they have the same signs? Well, this is above the x-intercept, is above the blue line, so it's positive. And the pink one is below the blue line, so it's negative. So does it work? No, it doesn't work. They're not the same. So let's check in group 2. So in group 2, we've got this one being below the blue line, so it's negative, and this one also being below the blue line, so it's also negative. And when you multiply them, it's positive, right? We wanted them to be the same, so it works. And let's check this little group over here. So the pink line is above the x-axis, is above the blue line, so it's positive, and the turquoise one is below the blue line, so it's negative. So now we're going to have negative and positive. So now it doesn't work, right? It doesn't work because the pink graph is positive and the turquoise one is negative at that portion. So now let's check the final group. So in the final group, we have the pink graph being above the blue line, so it's above the x-axis, so it's positive. And then we've got the turquoise one also being above the x-axis, so it's also positive. And if you check, they're the same. So hence it works because positive times positive divided by positive is positive. So these two groups work. So group 2 and group 4. And we also have to be careful. The denominator is not allowed to be 0, right? So wherever we have the x-intercept of h, we have to put double lines. So this is the first x-intercept of h that we see. Do we have another x-intercept? No, we don't have another x-intercept of h. So now it's time to describe the groups that worked. So notice group 2 actually starts from -4 and it ends at 2. So in interval notation, we'll say x is an element of, so it starts from -4, it ends at 2. So now let's talk about the brackets. Well, according to this question, this is supposed to be square, but we have double line here, so it's gonna be curved. And then this side is gonna be square, right? Because of this part, so it doesn't have a double line, so it will agree. So now we'll say, oh, then we have to describe the fourth group. So now the fourth group actually starts from +1, right? And it has got no end. So this particular group starts from +1 and it has got no end. So it will start from 1 and it will end at infinity. Infinity always has a curved bracket. So now notice this is an asymptote, right? This is an asymptote. So whenever it is an asymptote, irregardless of the question, it will always be curved. It's just like infinity. With infinity, it will always be curved. Also, whenever the critical point have got is by the asymptote, it will always be curved. So that's how it is. Yeah, so we don't even have to check. It's always going to be curved. So this is how it is in inequality notation, or rather in interval notation. Now let's talk about it in inequality notation. So this first group, we had the start and the end. So x is going to be between. So we're going to say x is between -4 and 2. So it will always be facing like this. According to the question, they are both supposed to have equal signs, but we have to be careful. Let's check where are the vertical lines. So we've got double vertical lines at -4, so meaning that this part will not be equals to. And then here we do not have double vertical lines, so this part will be just like the question. So it's gonna be equals to as well. So now we're gonna say, now we're gonna talk about this part. So now this group, it starts from 1 and then it has got no end. So, and as we can see, we have an arrow pointing to the right. So we have to say x, so x must be greater than 1. And then if it's an asymptote, it's the same situation. We'll not put an equal sign. So every time I've got an asymptote, it's always greater than only or less than only. All right. This brings us to the end of this video. So if you enjoyed this video, please like the video and subscribe to my channel. Also share my videos to support me. And if you've got any questions or any video you want me to make, please comment below. See you in the next video.